Hello everyone, good afternoon. Welcome to the session today. My name is Karan Hindocha and I will be your facilitator for the session today. We welcome you all to another learning session on AISC Challenge of the Year. The topic for today is AI Project Cycle. The topics that we will learn and understand today will help you for two reasons. One, it will help you to complete your idea submission document whose deadline is 15th December 4 p.m. Remember to submit your project ideas by 15th December 4 p.m. So this session today will help you complete a very important part of your idea submission document called problem statement. All right. So that was one. Secondly, this session today will help you to convert your idea into reality. What are the steps that you have to take? What are the processes that you have to follow to convert your idea into reality? You will understand that through the session today. So without further ado, let's begin the concepts to be covered in the session today. All right. So the topic is AI project cycle. Now, in school, whenever you have been asked to create a science project or make a science project, you would follow certain steps. You would follow a certain instructions, isn't it, to complete your project right from its start till the end. What are those steps or processes that you follow? First, you would think, what is the project going to be all about? What is the topic? What is the idea? What is the problem that I'll be picking up and making a project on it, right? So once you have identified that, you will start collecting all the materials that you would need, to build that project. You may even make a list first and then start collecting those materials, those minute things that you need to complete your project, to build your project. So once you have collected all the materials that you require, you'll start visualizing where does each and every material go, how will it piece together so that the final model will look something like this. So you'll try to visualize it and then you'll start building it. You'll start to join all the pieces together. You will start to build a physical model. And once you have completed that, it's time to show it to your friends, your classmates, and to your teachers. But before that, you do something very important, which is to check whether your model is working well or not, whether the process or the phenomenon that you want to demonstrate through your project, is it working or not? Are you able to demonstrate that to your audience? You check that once, isn't it? Or you maybe check that twice, right? Just to be double sure that, okay, it is working well. Once you do that, it's time to show your project to your friends and classmates and your teachers. So this is how you followed a certain steps, certain processes to convert your project idea into reality. So similarly, whenever you work on an AI project or an AI enabled solution, you follow certain processes, you go through certain stages, at the end of which your idea will now be converted into reality. So we call that AI project cycle. You may have seen a lot of AI processes on the internet, but these specific stages are related to AI, hence its name AI project cycle. So in an AI project cycle, we have 6 stages. First, we will briefly understand what are the objectives of each stage, and then we'll start exploring each stage in a bit more detail. So the 6 stages are problem scoping, data acquisition, data exploration, modeling, evaluation, and deployment. All right, let me repeat: problem scoping, data acquisition, data exploration, modeling, evaluation, and deployment. Now let's go through the objectives of each and every stage and then we'll start exploring it one by one. So the first stage is problem scoping. Now here in this stage, the objective is to define the goal for your project, to define the objective of your project. And this is one of the most important stages of your AI project cycle, because to get a good outcome of your project, you need to define a really good goal, isn't it? So depending upon the problem that you identify, you need to define a really good goal so that you get a good outcome towards the end of the whole project. So this is the problem scoping stage. Next, we have data acquisition. Let's split this term into two: data and acquisition. What is data? Data means information. We learned earlier that for a machine to become artificially intelligent, it needs data, right? It needs that information to learn from it, and then it does the task. So for a machine to understand the data, we need to acquire it first. So that is what this whole stage is all about, to acquire the data, to collect the data that is essential to build your project. Next, once you have collected the data in the second stage, in the data exploration stage, we explore the data. We visualize the data and try to understand patterns and the relationships between the data features. And we also look for any anomalies or any mistakes in the data set. We clean it, we visualize the data, and we explore the data through various graphs and charts to get a really good idea about what the data set is all about. What kind of model will can I choose, for, let's say, to do weather forecasting or to do any other task that we intended to do? What kind of model would we have to choose in the modeling stage? That is what we understand from the data exploration stage. And then in the modeling stage, here we are looking into the algorithms. We train the algorithms with the data that we have collected earlier, so that whatever task that we want a project to do, let's say it is predicting whether a person has worn a mask or not. So we write a model for it. We use a certain algorithm to do that prediction. So all of that, the modeling part, the algorithm, changing part, the coding part happens in the modeling stage. Next, once your model is ready, once you have trained your model to do a certain task, it's now time to evaluate its performance so that we know whether we should use this model or do we make changes to it, or do we even make changes to the data set that we've collected. So all of this can be understood in the evaluation stage to evaluate the performance of our model. Just like in schools, your performance is evaluated with exams. Similarly, for an AI model or for an AI algorithm, the evaluation stage is going to evaluate its performance. How is it making the predictions? Is it accurate, and so on and so forth. Now, once you are satisfied with the performance of the model and you think that this model is ready, the project is ready, it's now time to deploy the project. What do I mean by deployment? It means that, to prepare your project, to prepare your model, so that people can use it in a way that they feel comfortable, maybe in the form of a website or a mobile app. For example, let's say, vegetable price prediction. So if people want to know what are the vegetable prices in January, right, they can go to a certain website which you have made, which is working on the basis of your AI model that you've built. And people are giving some inputs, they are getting the predicted prices as the output. So that is what we mean by deployment. So these are the 6 stages of your AI project cycle. Now we will explore each and every stage one by one. We will begin with problem scoping. Now, like I said, the objective of the stage is to prepare a goal for your project, to prepare a problem statement that defines the problem that you have identified and how will you approach to solve this particular problem. To do that, we follow a particular method called 4W's problem canvas. Now, these 4W problem canvas helps you to understand about the problem in a bit more detail. This will give you a lot of insights about the problem that you have identified, which will, at the end of which, you will get a sense of direction as in how will you proceed towards the solution. So let's begin the 4W's problem canvas in this stage. So the 4W's in the 4W's problem canvas are who, what, where, and why. All right, so these are the 4W's: who, what, where, and why. Let's begin with the first W, which is who. Now, in this particular canvas, we are looking at the people who are facing the problem. Who are the people who are facing the problem? And those are the ones who will benefit from the solution that you will make, isn't it? So we call them as your stakeholders. And then we try to understand about them. So for example, let's say that you've identified this problem that people are facing a lot of problem to buy vegetables at the right price because the prices are unpredictable, right? So because of which they're facing a lot of problems to buy certain materials, certain ingredients at the price that they want and in huge quantities so that they can prepare a certain traditional dish, or maybe they want to maintain a family tradition. Like let's say in December they make let's say a pickle, right? This is their family tradition. And to do that, they would require certain items to make that pickle. Now, if the prices are unpredictable and they're high when they go to the market, that's they're facing a problem. So let's pick that as a problem, and let's try to do the 4Ws problem canvas with that example. So like I said, who are our stakeholders? People who are facing the problem and those who will benefit from the solution. So here in the vegetable price problem example, who are your stakeholders? People, isn't it? You may even be a bit more specific. Housewives and mother-in-laws or daughter-in-laws who make this pickle together, right? Or elders who make the pickles, right? These are your stakeholders. They are facing the problem that the prices are high when they go to the market to buy the ingredients. So your these people would be your stakeholders. What do you know about them? So these are the people who make a pickle, seasonal pickles, and they have this family tradition to make pickles. Let's say in December, and they need a certain ingredients, and they pass on this, recipe to their, from generation to generation, and that's how the family tradition is maintained. So this is what we know about them, that they have a family tradition. They need certain items to make that particular pickle at this time of the year. So your stakeholders are people who make that traditional dish. And what do you know about them? They pass on their recipe or their tradition from generation to generation, and they do this every year. So that sort of information you know about them, right? So now let's go to the next canvas. After who comes the what. So in the what canvas, we are looking at the nature of the problem. We try to understand what is the problem that our stakeholders are facing. In the who canvas, we identified our stakeholders, right? So we try to understand what is the problem that these stakeholders are facing. And we also try to find out how do we know that it is a problem? What kind of evidence do we have to support our claim that yes, this is the problem that they're facing? So if we take the example of the vegetable price predictor problem, so in that case, in that example, the problem that the people are facing is that the prices are unpredictable. Let's say that the prices are unpredictable due to poor harvest conditions. Okay, for example, now due to this poor harvest conditions, they are not able to purchase vegetables at the right price at the time of the year that they want to, because the prices are high. If the harvest was poor, there would be less quantity available in the market, and when they go to buy it in the market, they would see that the prices of those vegetables are very high. So that is the problem that they're facing. Now, how do we know that this is a problem? How do you, support your claim that this is a problem and I want to solve it? So you must have seen, in the news that the news reporters are reporting about this problem. They are reporting about the rise in prices in the news. You may have read it in the newspaper. You must have observed yourself when you go to the market. You must have observed that, you know what, in November, let's say the price of cabbage was, let's say 40 rupees. And in December, it is now 65 rupees. So there is a difference of 25 rupees in these 2 months. So that is how you know that it is a problem, that when I want to purchase cabbage in, in a huge number, right, in bulk quantity, I go to the market and I see that the prices have increased and I didn't know about it. That's the problem, right? And how do you know that it is a problem? You've observed it by yourself. you may have even read it in the news or read it in the newspaper, right? So that is how we know that it is a problem. That supports your claim. That evidence supports your claim that yes, this is a problem. So in the what canvas, we understand the nature of the problem. All right. Moving ahead, we go to the where canvas. Now, whenever we hear the word where, we think of the location, isn't it? Like maybe in Mumbai or in Hyderabad or in Delhi, people face this problem. But in case of the 4Ws problem canvas, when we look at the word where, the where canvas, here we are understanding in what context or in what situation these stakeholders face the problem, right? Whatever the problem that we understood in the what canvas, in which context or situation are they facing that problem, or are they experiencing that particular problem? So we need to describe that situation. So if we take a look at the vegetable example that we're looking at, the context or the situation in which our stakeholders, which is our people, uh, in which they are facing a problem is when the harvest conditions are poor, isn't it? When the harvest conditions are poor, when they go to the market to buy the ingredients in huge quantities, they face a lot of problem because they're not able to buy the right amount of ingredients that they want to prepare that dish, right? So they may want to compromise in that situation, because if a certain ingredient is expensive, they will try to look for alternative ingredients which are cheap but will still do the trick. So which is why this is when the people are facing the problem, that due to poor harvest conditions, the prices are high when they go to buy the vegetables in the market. Okay, I hope you're able to understand this. Great. So after the where canvas comes the why canvas. Now this is one of the most important canvases, because here in this canvas, you need to ask yourself this question: why do you believe that this is a problem worth solving? Right? Now this why gives you a motivation to solve the problem, to determine a solution for it. Here in this canvas, we are looking for something very important to the stakeholders, something of key value to the stakeholders, because of which their problem will be solved, the situation will improve. So what is that something important that will help the stakeholders to improve the situation that they are going through? So here we start to look for possible solutions which will solve that problem, because that key value to that stakeholders is your solution. So let's say if I take the example of the vegetable problem, right? Let's say that the key value to the stakeholders would be a price predictor, right? Imagine this, that if people are looking at the predicted prices before they go to the market and buy it, they can plan their purchase accordingly. They can prepare themselves even for the worst case scenario in case the prices go high. So that is something of key value to the stakeholders, right? And if they use this particular solution, let's say they go to website, they put in the inputs and they get the predicted prices, that would improve their situation so that they can purchase the vegetables at the right price that they want and at the right time of the year that they're looking for. So this helps to solve their problem and improves the situation. So that is why it is worth solving this problem, because you have found out that key value to the stakeholders which will improve their situation. So I hope with the vegetable price problem, you understood how to go ahead with these 4Ws problem canvas, right? So let me repeat this once again. In the who canvas, we are identifying who are our stakeholders and what do we know about them. In the what canvas, we are looking at the nature of the problem. What is the problem that our stakeholders face, and how do we know that it is a problem? In the where canvas, we are looking at the situation in which the stakeholders experience the problem. So once we have answered all these questions, we go to the why canvas, where we ask ourselves, why do you think it is a problem worth solving? What is that key value to the stakeholders which will improve their situation? So what would the ideal solution be in this case is what we're looking for here. So once you have answered all these questions, it's time to put together all the 4Ws into a short paragraph that will define the goal of your project, that will define the problem statement of your project. And with this problem statement, you will get a sense of direction as in how will you proceed towards the solution. What type of data would you need? Maybe what kind of model, can you select to solve that particular problem? You can get, a brief idea about that. So let's take a look at the problem statement now. So to combine all the 4Ws into a paragraph format, which makes up your problem statement, there is a template that you can follow. We call it the problem statement template. So how do you, create your problem statement with the 4Ws? So you can write your problem statement in this manner. Our stakeholders have a problem, that so and so problem that they're facing when this particular situation occurs, and an ideal solution would be so and so. So if we take a look at the vegetable price problem, our people have a problem that the prices of vegetables are unpredictable when the harvest conditions are poor and they go to the market to purchase the vegetables. An ideal solution would be a price predictor model for the people to predict the prices of vegetables in advance. So you see, earlier I only had an idea of what the problem is, which problem have I picked to solve. But only when I've gone into a bit more depth into the problem, I've got a clear idea what my problem is, what the problem that I'm going to solve, what would be the ideal solution to that. So you formulated the whole 4Ws canvas into a problem statement. Now this problem statement will define your objective of the project. Like you define your objective for your science projects in school. Similarly, we have this objective of your AI enabled project. So this problem statement is very important, right? And through this segment of the session today, I hope you've got an idea of how to prepare your problem statements for your individual projects. So if you are ideating more than one idea, then for each idea, you will have a separate problem statement in that document. So I hope you've got a clear idea how to start with the problem scoping stage and how do you formulate your problem statement. Okay, so this was about the first stage, which is problem scoping. Now let's move ahead to the next stage, which is data acquisition. Like I said, the objective of this stage is to collect data. So let's speak a little bit more about the data, right? What is data? Data is nothing but information, the raw facts, the raw information based on which you learn. So if we take our own example, we learn a lot of things, and the information that we get to learn about the different aspects of our life, or maybe in school also, that is information to us, and that information is data. Similarly, for a machine to become artificially intelligent, it needs data. So it needs the information to learn from it and do the task that we intend it to do, right? That is data. Why do we need data? Like I said, for a machine to become artificially intelligent, it needs data. So for example, if you're learning about algebra, for example, you learn through some examples, right? And then to solve that, if an unknown question is asked to you, using the information that you got to learn that concept, you were able to solve the unknown question. Similarly, the machine needs data so that it can learn from the data that we provide to it, so that it can make predictions based on unknown data. For example, weather prediction. You give data to the system in the form of the weather information of your locality. It learns from it. It learns based on certain factors. How does it predict the weather? And then when you provide it with some unknown input, it should be able to predict the weather for you. That's why we need data. Then the next question that might come up in your head, is where do we get the data from? Well, there are a lot of sources from which we get data. You have reliable and authentic websites, government portals to get data from. You have sources and platforms like Kaggle or GitHub, where there is a wide repository of data sets. And you can go onto those platforms, search for the data set that you need, and you can access those data sets very easily. Now, since it is open sourced, which means that people from all over the world are sharing that information with you all, sharing the data with you all, which you can access. Not just that, other sources can be surveys, interviews, your own observation, right? Inputs from other sources like, API, joystick, right? Cameras, sensors. These can also be sources from which you can get data from. And using that data, you can, uh, you know, create your project. But what are the different types of data? In yesterday's session, where we, no, in the previous learning session, where we looked at basics of AI, we also looked at the three main domains of AI. Now, to understand those domains, we looked at the types of data that is required, to develop an application on that domain. So the different types of data that we learned were you have numerical, alphanumerical, images, videos, text, and speech. All this is different types of data. Okay. Now, before we go ahead into this stage, let's understand another very important term, which is data features. What is data features? Data features is nothing but those features of your data set which helps you to build the model, which helps you to make the predictions that you want to make. For example, if you want to do weather predictions, right? If you want to forecast the weather, so information about weather will be collected in this stage, isn't it? So from that data set, all those features of your data set which will help you to forecast the weather are your data features. For example, precipitation, humidity, rainfall, max temperature, day, and so on and so forth. All these features will help you to forecast the weather. They are called data features. All right. So let's take a look at it in the form of an example. Look at this image. I'm sure you must have got a brief understanding of which problem are we trying to look at here. So the problem that we are trying to solve is how might we predict the exam scores of students? So if you want to predict your next exam score, how might you do that? What data features do you require in your data set to be able to make such predictions? So let's say that you require data features such as number of hours you study, subjects, previous marks, extracurriculars, assignments submitted, right? Number of hours you sleep, right? Any extra tuitions that you take, how many hours you study in the day, isn't it? So all these features play an important role to predict your next exam score. So these features, if you find it in a data set or you collect it in a data set, you can use that to make your prediction for the exam scores. Similarly, for your project also you can do this. Once you have formulated your problem statement, think of the data features that you might require to to convert your project into reality, to build that particular model. What type of data features do you need for you in your data set? Think of those data features and search for the data set accordingly. Once you have collected the data set, check whether your data set has those features or not. And if you need to collect more features, you can also continue to collect more data, right? So this is how, in a brief manner, you proceed in this particular stage. So I hope this was clear to you. Now we go to the third stage, which is data exploration. Once you have identified your problem and you have collected the data set, it's now time to explore it. What do you do in data exploration? It's all about data cleaning and visualization. Let's take a look at these two terms or these two terminologies individually. Starting with data cleaning. What is data cleaning? When you collect a data set, right, you may find certain mistakes in it. you may find certain anomalies in it, and these errors, if they are present in your data set, are not good. Because if your data set is not accurate, your model will not give you accurate predictions because there are mistakes, there are errors in your data set. What are those commonly found errors? We have outliers, missing data, and erroneous data. Okay, so let's start with erroneous data. Erroneous data is nothing but incorrect data points or wrong data in your data set. For example, let's say you are collecting information of different people through surveys, right? And let's say you are asking for their age, for instance. Okay, so if someone is writing the value of age as, let's say, 250, that's wrong, isn't it? How can someone's age be 250, right? So that is erroneous data. That's incorrect data. If we talk about missing data, these are the data points or the values in your data set which are missing. So what do I mean by missing? Let's take that same example where you're collecting information of different people through a survey for your project, and you're asking for their age, for instance. If they don't feel comfortable sharing their age with you, they might leave that particular section blank, right? They might not give you their age for their whatever information that they're sharing with you through that survey. So that is missing, isn't it? A particular person's age is missing in your data. That's missing data. Okay. And then we have outliers. Outliers are those data points which exist outside the range. For example, let's take the instance of marks, right? Now, normally marks range from 0 to 100, isn't it? Or 0 to 50, for instance, depending upon whatever the type of exam is. So normally, if marks are ranging between 0 and 100, right, we see that if a certain student has got marks, let's say 140, that's not right, isn't it? Even though we wish we get 140 marks, right? But no, 140 out of 100 seems like an outlier because it falls outside the range. That's an outlier. These commonly found errors and mistakes need to be handled before you feed the data to the model. All right. Now comes data visualization. Why do we have to explore the data? Now, whenever we are looking at, let's say, a tabular column of data, right, we would have numbers and numbers in it. But just by looking at it, would you get a sense, can you try to identify a pattern or a trend or some relationship between the two data points? Can you try to get a sense of all of this within the data? No, right? Because it's all numbers. And there are a lot of numbers. In fact, there would be numbers in thousands and in millions, right? If you just look at those numbers, you won't get a sense of any trends or patterns or relationships contained within the data, which is why we explore the data set that we have collected. It also helps us to define the strategy that which model will be used in the modeling stage. So depending upon the type of data that you've collected and the problem you're solving, you might you will have to select a model in the modeling stage. So to do that, it will become a bit easier for you by exploring the data set. Also, if you visualize the data set, it's easier to understand, isn't it? If you're looking at numbers, it's very hard to make a sense out of it, right? But if you are visualizing in the form of various graphs and charts, your job becomes easier. And if you want to communicate that information to others, that, you know what, I find this particular pattern in the data set, right? I feel that there is a linear relationship between height and weight. So I think I should use a model which establishes a linear relationship between these two factors or these two features. That sort of understanding you get from by visualizing the data from the graphs and charts that you plot. So that explains this particular slide here, where if you're looking at the numbers which you see on the left, that's difficult to understand. But if you visualize that in the form of graphs and charts that you see on the right here, it's a bit easier to understand, right? There is some sort of pattern here which you can figure out, and you can try to get some insights from the data set, which will help you in the modeling stage. So visualization is easier to understand and communicate to others. That's data visualization. Now, I spoke about graphs and charts, isn't it? What are the various graphs and charts which will help you to visualize the data? We have bar graphs, line charts, scatter plots, we have histograms, box and whisker plots, and so on and so forth. All these graphs and charts will help you to visualize the data to your own needs, extract the insights from it, and understand what type of model do you think you should be selecting in the modeling stage, right? How would you approach this particular solution? Which model will you select? And how will it work? Will it suit to your data set or not? That sort of questions will be cleared as you visualize the data. All right, great. Now let's move ahead with the fourth stage of our AI project cycle, which is modeling. Like I said, the objective of this stage is to write algorithms or codes or make some changes to pre-trained algorithms to your particular project so that you are creating your project which will do a particular task. If you are creating a project to detect whether a person has worn a mask or not, you will create such a model. If you take the vegetable price problem that we saw earlier, you can create a model or you can choose a model which will help you to predict the prices of vegetables given the input of certain features of your data set, right? So that comes under modeling. Let's see the stage in a bit more detail. For that, we'll understand the difference between AI, ML, and DL first. We've all understood what artificial intelligence is, right? It's a technique that enables computers or machines to mimic human intelligence, right? Now, what are machine learning and deep learning, and how are they different from all the three? So we can, if you see the graphic on the left, we have the term artificial intelligence on the top. So this is like the umbrella term, right? And machine learning and deep learning are its subsets, right? So what is machine learning? It's a subset of artificial intelligence that enables machines to improve at the tasks with their experience from their own learnings. How does a machine improve in its tasks without being explicitly programmed? That is machine learning. Now, we may have used machine learning applications in our day-to-day life. For example, recommendation engines on Spotify and Netflix, or Google search engines, right? And voice assistants. All these are, come under machine learning, for instance, right? If you take a look at deep learning, on the other hand, deep learning is a subset of machine learning, right? Now, deep learning is created by getting inspired by the way our human brain works. So the way you understand, process, and filter the information, deep learning also works in a similar fashion, right? So it is a subset of machine learning in which the tasks that it performs require a lot of data, vast amounts of data. And each deep learning model has several nodes. We'll speak about it in a bit more detail further in the slides. But deep learning basically does tasks that require a lot of human thinking to do. For example, if we take a look at self-driving cars, right? It takes a lot of decisions from the inputs that it gets from the surroundings, right? Like the distance of the car in front, exit points, how much speed should it maintain, whether a speed bump is coming or not. When we drive, we get all of this input, we think, we process, and we take a decision and do a particular action. So similarly, even a self-driving car does something like that. So that would be the best example of deep learning. Okay, so now that we have understood the difference between AI, ML, and DL, let's take a look at the some of the machine learning models. So there are three types of machine learning models which we can broadly categorize into supervised, unsupervised, and reinforcement learning. What is supervised learning? So take a look at this example here. In supervised learning, we are supervising the learning that the machine does, right? For example, Let's say that we have collected 100 images of apples and bananas. For each image, we have labeled it as apple or banana. And we are feeding the data set as well as the label to the machine. It is trying to understand the data that, okay, this is an apple. There is a name to it, apple. There is a name to this image, banana. Okay, now I'm ready. You test me. So when we test the machine with an unknown image of an apple or a banana, it will tell you whether it's an apple or a banana. That is supervised learning. You're supervising the learning process of a machine so that it learns from examples. The images that you're showing to the machine with in the form of data are examples for it to learn. And you can test its learning with unknown data. All right. So I hope you've understood what is supervised learning. Let's take a look at unsupervised learning. In unsupervised learning, as the name suggests, we are not supervising the learning process of the system. If I take the same example of apples and bananas, right? Let's say we have collected 100 images of apples and bananas, but we have not labeled each and every image as apples and bananas. We've simply collected the images and we are feeding that as an input data to the machine. The machine will look for patterns or differences or similarities in the data and learn how to make clusters of data, how to make groups of apples, how to make groups of bananas, and tell us that, you know what, from the data set that you have shown me, these are apples and these are the groups, this is another group for bananas. So it make clusters depending upon the different data that you have. So if I have to explain with another example, let's say that you have 50 children in a class and you as a model have been asked to make clusters of boys and girls. How will you do it? You will look for similarities, you look for differences between two people and make clusters of boys and make clusters of girls, isn't it? Then the next time when an unknown student is entering the class, depending upon their similarities and differences, you will put it into that respective cluster, whether that person falls under the cluster of a boy or a girl, right? That is unsupervised learning, right? You're not supervising its learning. And the data set is not labeled. That's the difference between these two processes. Major difference is that supervised learning, the data set is labeled, and in unsupervised learning, the data set is not labeled. It's unlabeled, right? Next comes reinforcement learning. What happens in reinforcement learning? I'll explain this with in the form of an example. I'm sure we play a lot of games, isn't it? Video games. How does the video game work? We have certain levels that we need to cross in order to complete the game, right? Let's say you are at level 1. To complete level 1, you will take certain actions and you will make certain moves. And based on that, you will either complete the level or you will not complete the level. If you complete the level, you get certain rewards, right? Like maybe 3 stars or 3 gems, right? Things like that. They are your rewards. So that you will go on to the next level, and you can only go to the next level if you have completed the level with your best actions, isn't it? Right? If you do not complete the level, right, if you do not take the best action, you do not complete the level, which means you have to do this process all over again. You may change your strategy, you may change your moves, or you may take a different action to complete that level, right? So based on that, you will get rewards. So either you get a positive reward that you've completed the level, or you get a negative reward and you try again with some different action. That's how reinforcement learning works, right? It works on the basis of an action taken in an environment, and based on that action, it gets a certain reward to complete that particular step. Let's say you've built an AI enabled robot whose task is to go from point A to B, right? So you won't be giving any information about obstacles in its way from A to B, but instead you are giving real-time data to it, And based on that real-time data, it takes a certain action to go from point A to B by avoiding all the obstacles. Maybe it has to turn left, it has to jump, it has to, bend down and go underneath that obstacle, those sort of things. That is how reinforcement learning works. All right, so I hope this is clear to you. How does reinforcement learning work? So this was about the 3 types of machine learning models. Now, if we take a look at common machine learning algorithms, we have generally 3 types: classification, regression, and clustering. What is a classification model? In classification model, you are classifying the data into its respective classes. For example, in supervised learning, we saw that the machine is classifying the image into apple or banana. So it is classifying into apple class or banana class. That is classification, right? On the other hand, no, one more point. In classification, the output that you're predicting, whether the particular data goes to this class or that class, that depends on the categorical variable, meaning apples, bananas, cats, dogs, boys and girls, all these are your classes. And depending upon these classes, you are separating your data, or you are classifying your data into those respective classes which are categorical variables. On the other hand, regression is when the output variable is a continuous variable, meaning you're trying to predict something which is changing over a period of time, like fuel prices, um, gold prices, right? Those sort of predictions we can make using a regression model. Not just that, you can even predict whether an unknown person is having cancer or not, or whether that person is a heart patient or not, or whether that person is diabetic or not. That sort of predictions can also be made using regression model. And classification and regression falls under supervised learning. Clustering falls under unsupervised learning. So like I said, what is clustering? Groups of similar data together. Groups of boys at one end of the room, groups of girls at one end of the room. That is clustering, right? Clusters of apples, bananas, grapes, mangoes, right? We have all these data points in its respective clusters. That is clustering. Okay, great. Now we have one final topic to cover, which is neural networks in the modeling stage. So what are neural networks? As the name suggests, neural networks are loosely modeled after how neurons in our brains behave. For example, uh, the concepts that I'm explaining to you right now, you're able to hear me, you're able to understand the information, you're able to store it in your memory. And if any question is asked to you, you're also able to give me an answer to that, right? So this is how our human brain works, isn't it? The way it filters and processes information, right? That is how it works because of the neurons that are there in our human brain. Similarly, in a neural network model, there are neurons, and these neurons are nothing but the basic building block of a neural network model, or the basic structure of a neural network model. And a network of all these different neurons make up your neural network model. Now, what are these neurons? These neurons basically extract data, or it extracts information out of the input that you provide to the system. And it extracts that information and it understands what are its different features, what am I trying to, what am I looking at, and it collectively understands the whole data set, and it gives you a certain prediction in the output. So the way it does is through different layers. Each layer has a specific role. And in each layer, there are specific nodes. So let's say that there are 100 nodes in the first layer, 200 nodes in the second layer, like that. So each node is essentially a machine learning algorithm which has a particular or a specific task to do. And based on that, it extracts the features, or it does the task. It passes on the information to the next neuron, then to the next, then to the next, and so on, until the machine or the model gives you an output. For example, if you show an image of a car, right? So if you have data set of images of cars and you feed that to the system, The neural network model is going to extract features of the car and try to identify what this object is. It will then collectively put the information together at the end and give you a prediction that, you know what, I think 70% this image is a car, 20% this is a truck, 10% this is a bicycle, and so on. So this is how it gives you, it analyzes the information and gives you a certain prediction at the end. Neural networks are useful particularly when you are trying to solve problems when the data set for it is very, very large, right? Because traditional machine learning algorithms cannot handle such huge data sets, right? Which is why you can go on with neural networks, to do that task, to create your project accordingly. Now, I was talking about the different layers. So in a neural network model, there are three main layers. We have input layer, which gets the input from the system, right? It passes on the data, that information, to the next layer, which is the hidden layer. As you see, the yellow circles is your input layer. The purple circles are your hidden layers, and the orange circles are your output layer. So the hidden layer gets information from the input layer. It extracts whatever features it needs to extract. It understands the data. It understands the entire process, and then it gives all that information to the output layer. And what does the output layer do? It gives you predictions that, you know what, first output layer is predicting that this is a car. Next one predicts this is a bike, this is a truck, this is something else, right? That's how it makes the predictions, by analyzing and processing the data. So this is how neural networks generally work, right? So with this, we come to an end of the modeling stage. Now the final two stages are evaluation and deployment. In these two stages, uh, starting with evaluation, we see that how does our model perform. We have created the model. Now we will check how is it performing. And if you're satisfied with its performance, we will deploy it so that people can use our solution and they will benefit from it and the situation will improve. This is the whole AI project cycle. I hope you've understood the entire project cycle, the objectives of each and every stage, and what are the processes that you follow in each and every stage to convert your idea into reality. Okay, now you can also do this. You can also go through the 4Ws problem canvas, prepare your problem statement, and put it in your idea submission documents. You can also collect the data, explore, visualize, and prepare your data set for the modeling stage. You can build a really good model, evaluate its performance, and then you may even deploy it. For the challenge of the year, you need not deploy your project. You can simply just create your project and evaluate it, right? You don't have to deploy it in the form of a website or something. If you can do that, that's really great. But if you think you won't be able to do it, you can work until the evaluation stage only. That's totally fine, as we would get an understanding whether your model is able to solve that particular problem or not. So if the problem chosen by you was to detect whether a person is wearing a mask or not, right? When we evaluate your model, we will see whether your model is predicting whether I've worn a mask or not, right? So you can also do this. We wish you all the best in your participation. We are excited to see what new ideas do we get, in your submissions, and we look forward to evaluating them. Let me remind you that the idea submission form is shown here on my screen and will also be shared with you in the chat section in case you have missed it. The idea submission form has also been uploaded in the forum thread AISC Challenge of the Year. It was also shared with you via email. In case you missed it out, make a note of the form here from my screen, and you can submit as many ideas as you can. Per submission, you can only send one idea, right? So let's say you have thought of 3 ideas, you will have to submit this form 3 times with individual ideas. All right. Also, mark your attendance for the session today, whose link will also be shared with you in the chat section. All right. So do make a note of the idea submission form and mark your attendance for the session today. When you mark your attendance, select the session as AI project cycle and mark your attendance for the session today. All right. So thank you so much for joining the session today. It was great to have you here. Thank you so much for joining. Have a great evening. Take care and bye-bye.